and that counts down. So please do stop when it hits 0. All right, yeah.
Okay, hi everyone. So we're going to talk about secure governance, specifically about multisig transactions, which is the main part of the governance on a blockchain-based company. I'm the CISO at Ensuro, and I'm mentioning this because we are an actual blockchain-based company operating for the past 4 years, and we use this a lot. So this is a set of tools that we built. And the problem we're trying to solve is that blockchain protocols evolve. We have to deploy new smart contracts when a new customer is onboarded, so we have configuration changes, we have permission changes, and we have funds being moved around. And the way that the Safe UI shows these transactions is hard to review, especially for a non-technical user, which is the one that the ones that are authorizing these transactions on our company are not all technical. So our CFO authorizes transactions and he's not technical. Our CTO authorizes transactions and he is technical and he can read this call data and probably figure it out, but the CFO can't. So that's the problem we were trying to solve. And the way we do this is, first of all, we defined a chain set, which is the definition of a multisig transaction that we want to execute. And here we say, okay, this is going to run through this specific multisig. This is going to use a time lock and the delay defined for that time lock. And this is what's going to be run, right? This step. This is going to be a contract function call with these parameters. And the parameters are an address, which is expressed as an address alias, and an enum in this case, and it's expressed as the value in the enum, not as a 0 or a 1 or a 2 or whatever index in the enum corresponds. And this is probably the most useful part of it all. We can define tests right there in the chain set, right there in the multisig transaction definition. And these tests are run before sending the transaction to the safe multisig for signing. This is the first part, and this can be created. This chain set can be created by a non-technical user. It's not very difficult. It's a very simple format. It can be created by an intern. It can be created by a junior member of the team, or it can be created by an LLM. Once we have this, goes on a pull request on a GitHub repo, because this is code in the end. It goes through a review process. Once it's approved, there's a workflow in a GitHub Actions, in our case, that creates the safe multisig proposal. And that's the only permission that this action has. It's a delegator on the multisig, so it can only create transactions but cannot sign them. And the person that created the chain set has no permissions at all on the multisig, only our workflow. So this creates a proposal on safe multisig. And of course, we were still having the problem that when the users, the signers, were ready to sign this, they were seeing this call data, especially when there were time lock and other complex contracts in the middle. So we also created a Safe UI app that is integrated into the Safe UI that shows this friendly definition of the transaction, which comes from the manifest that we saw before and from some intermediate artifacts of that, and shows step by step what's being executed. It shows the TX hash, and this is very important because on Safe there's several ways you can sign the transaction. You can sign an EIP 712 struct, but that's very difficult for a non-technical user to understand, or you can just sign the hash as a text, and that's what we are using for signing. And a hash is easy to verify to any user, right? You use your eyeballs and you check that the hash you are seeing on your wallet for signing, on your hardware wallet for signing, and the hash that you are seeing on the UI is the same. Besides that, we also have notifications on our Discord, internal Discord messaging service. And it also shows the hash, and it also shows the detail of the transaction that's going to be executed. This serves more of as a call out, you know, hey, you have this proposal, this transaction to sign, but it also works as a second or third check, because the hash that's being shown here, the SafeTX hash being shown here, is generated independently from what's being shown in the actual Safe UI. So a hacker would have to compromise 3 different parts of code, 3 different systems to compromise us. We actually added this after the Bybit hack, analyzing how the Bybit hack happened and how we could avoid it with our tooling. So yeah, this is kind of it. We just wanted to show these tools. We want to make these tools available. Actually, the Safe UI app is already open sourced. And the rest of the tools for creating the transactions and running the test and all of that, we can make them open if anyone is interested. We just need to put in some work to extract it from, from our system and open source it. And then as next steps, we are planning on adding in-browser verifications or even running the test right in the browser. So if you trust the app, you trust what you are seeing here. And then you can deploy the app on IPFS or some static hosting, and you can trust it that it doesn't change. Maybe ENS support, because right now we are using an internal address book, like a mapping from names to addresses. Using ENS would be really cool. So yeah, here you have my contact information. If you're interested in it, you can find me out there in a little bit, and contact me here. Thank you.
Cool stuff. Thank you.